Morning, everybody. So today we're going to go ahead and cover graphing polynomials. And there's several things we have to talk about. Some of them old, some of them new. The first thing we have to talk about is the degree of the polynomial. You guys have dealt with this before. It's the highest power of the polynomial. So if you have something like is 4x squared plus 3x plus 2, the highest power here is 2, so the degree is 2. Okay, if you had something like, 6x cubed minus 14x to the 7th plus 2, the highest power here is 7, so the degree of this polynomial is 7. We also have to learn something that's called the leading coefficient, which we've talked about before, but the leading coefficient is simply the coefficient that comes before the variable at the highest power. So that's the highest power, 2. So leading coefficient is 4. Here the highest power is 7, so the leading coefficient is negative 14. Okay, let's talk about end behaviors. End behaviors are what happens as the graph goes out in both directions forever. What does it go to? Okay, so there's 4 different basic ones you have to learn about here with polynomials. So the first is if we're talking about if the degree of the polynomial is even. So this one, for example, was even up here. So that's what we're talking about. So if the degree of the polynomial is even, it's either going to go up on the left and the right, or it's going to go down on the left and the right. Okay, now what happens in the middle? In the middle, I don't really care right now because I'm only worried about the end behaviors. So in this case, the graph might go something like this, okay, but once again, I don't care what happens there. Or maybe the graph goes like this, but once again, I don't care what happens there. Okay, so if the degree of the polynomial is even and the leading coefficient is positive, it's going to look more or less something like this. Okay, so the graph is going to go like this, and then the left end behavior, so on here, it's going to go to infinity. The right end behavior, it's also going to go to infinity because it goes up forever. Okay? Now over here, and I'm goofed up here, this should be negative. Okay? So now the degree of the polynomial is even, so it's going to do something like this or this, but the leading coefficient is negative, so it's going to go down from left to right. So it's going to, they're going down on both ends. So it might look something like this, whatever. Once again, I'm only really worried about the end behaviors. So the left end behavior, it goes to negative infinity, and the right end behavior also goes to negative infinity. Okay, what about if it's odd? If it's odd, it's going to do one of two things. It's either going to go up from left to right, or it's going to go down from left to right. Okay, this is if it's positive, that is if it's negative. I don't really know what happens in the middle here. I don't really care because I'm only worried about the end behaviors right now. Okay, so if it is odd, which is going to be one of these, and the leading coefficient's negative, it's going to be going down from left to right, something like that. Okay, so the left end behavior is going to be infinity, and the right end behavior is going to be negative infinity. Okay, so this should be positive now. Okay, so the degree of the polynomial is even. This should be odd as well. Okay, so the degree of the polynomial is odd and the leading coefficient is positive, so it's going to look something like this. Once again, I don't know what happens in the middle, so it could do something like this, whatever, I don't know. All I'm really worried about is what the end behaviors are going to be. So the left end behavior, it's going down, so it's going to negative infinity, and the right end behavior goes to positive infinity this way. Okay, and that's it for the end behaviors. Okay, what about intercepts? Okay, we have dealt with intercepts before. How do you find intercepts? So to find the x-intercept, you make y equal to 0. And to find y-intercept, you make x equal to 0. Now, one thing we haven't talked about is the maximum number of x-intercepts is this, or what is the maximum number of intercepts something could have. So the maximum number of x-intercepts is the same as the degree of the polynomial. Okay, so let's go down to the examples and then we'll come back to the terms in a second. Okay, so let's deal with the degrees here. Once again, the degree is the highest value. So in this case, it's 5. In this case, it's 6. In this case, it's 2. In this case, it's 7. Okay? Now, I just talked about what is the maximum number of the x-intercepts. It's the same as the degree. So, right here, maximum number of x-intercepts, same as the degree, that should be 5. This should be 6, 2, and 7. Okay? It's really simple. It's just the same. Okay, let's go down here and let's talk about turns. Okay? So a turn is a point on the graph where the graph changes from increasing to decreasing. So something as simple as like that. There's a turn there. Okay, if it went back up, there's another turn there. The maximum number of turns, the maximum, is 1 less than the degree of the polynomial. So there's the degree. The maximum number of terms must be 1 less than that, than 4. This would be 5. This would be 1, and that would be 6. Okay, now, what about the rest of these? To do the rest of these, you kind of have to, well, you don't have to, but I think it really helps to graph these to know generally what they look like. Now, it doesn't have to be an accurate sketch. Just, once again, we're just worrying about the behaviors. So, this is an odd function, which means it's either going to go up from left to right, or it's going to go down from left to right. It depends on what the leading coefficient is. But if you notice, the leading coefficient here is positive, so it's going to look like this. So the left behavior is going to go to negative infinity, and the right behavior is going to go to positive infinity. Okay, over here, we have an even function. So it's either going to go up and down, or so it's going to either like curve up like that, or it's going to go down like that. Okay, it is determined by the sign of the leading coefficient, which is negative, so we're talking about that one. So the left behavior is negative infinity, and the right behavior is negative infinity as well. Okay, down here, it's a squared function. The leading coefficient is positive, so it's going to look like some sort of a u there. So the end behavior is positive infinity on both sides. Okay, it's going to go up forever to the left and up forever to the right. Okay. Odd function, so it's either going to look like that or it's going to go down like that. This is a positive leading coefficient, negative leading coefficient. In this case, we have a negative leading coefficient, so it's going to look like this. So the left behavior is positive infinity, and the right behavior is negative infinity. Okay, the last thing we have to deal with is what is the minimum number of intercepts? Okay. So what you're going to do here is if you have a graph and this is the x-intercept, and so say it was like some sort of an odd function. So it could look like this, right? But this graph could also be up here somewhere, or it could be down there somewhere. So what you're going to do here is you're going to go to the graph of what you have, and you're going to draw in a horizontal line, and you're going to try and cross the graph as few times as possible, remembering that it goes up forever and it goes down forever. So you don't want to draw the line in here because it's going to cross more than once. But if you drew here, it's going to cross once. If you drew it down there, it's going to cross once. Even if you drew it up there, the graph continues, so it's going to cross once. So if it's an odd function, the minimum number of times it's going to cross is 1. Okay? So here's another odd function, it'll be 1. Now what about if it's an even function? Okay, if it's an even function and I draw a line through here, it's going to cross 2 places. If I draw it down there, it's still going to cross 2 places. But if I drew it up here, it's not going to cross at all. So if it's even, the minimum number is going to be 0. Even, minimum number is 0. Okay, next page. Okay, for the next 4 examples, sketch the graph using the x-intercepts, turns, and left and right end behaviors. Okay, so first off, I want to deal with the x-intercepts. We know to find the x-intercepts, you make y equal to 0. Okay, so f of x, that's the same thing as y. So what I'm going to do is I'm going to rewrite it down here, but instead of f of x, I'm going to write 0 because I'm going to try and find the x-intercepts. So I have 0 is equal to x times x plus 4 times x minus 2 times x minus 7. Okay, now look, you have 1, 2, 3, 4 things that are being multiplied times each other, and the answer is 0. The only way that that's possible is if one of these will be equal to 0. So x has to be equal to 0, x plus 4 has to be equal to 0, x minus 2 has to be equal to 0, and x minus 7 has to be equal to 0. Okay, well, solving 1, so I get 0. Solving this, I'm going to go minus 4, which is going to be right there. Solving this, I get plus 2, so it's going to be right there. Here I'm going to add 7, I'm going to add 7, so 5, 6, 7 is right there. So this graph is going to cross this x-axis in those locations. Okay, now let's talk about the degree of this polynomial. You have 1, 2, 3, 4 x's in there, and when you multiply them together, you're going to have an x to the 4th power. That means it's an even function. Now, what about the leading coefficient? The leading coefficient is going to be when you take x times x times x times x. All of those are positive, so the leading coefficient is positive here. That means my end behaviors are going to be going up like that and up like this. Okay, so how do you do the rest of it? It's really easy. All you do is you just have to connect this to that, but it has to go through those 4 points. So you're just going to snake it through. So it goes down here like this. When I go up, and then down, and then back up like that. Okay, I'm not really worried how far to go down here. I'm not really worried about how far to go up there. Right now, I'm just worried about going through those points. Okay, so let's go down here. So now when I multiply x times x times x, this is going to be a cubic function. And if you notice, x times x times x is going to be positive, but you have that negative in front, so this is a negative x cubed. That means the graph is going to go something like that. Okay, now where are its x-intercepts? If you solve this, 1, you're going to get negative 3. 1, 2, 3. If you solve that one, you're going to get positive 4. And if you solve that one, you're going to get 7. Okay, so the graph has to look like this. It comes down, goes up, and then back down again. And there we are. Once again, I could do some work to determine what this is, but that's not the purpose of this exercise. Okay, now these are a little bit different. And why these are different is you notice you have this squared here. Okay, that's what makes it different. Okay, so when you square x here, you're going to get an x squared, but then you multiply it by another x, so therefore you're going to get an x cubed. Furthermore, you have a positive x here, you're going to have positive x there, so your leading coefficients can be positive, so the graph is going to look something like that. Okay, where are its x-intercepts? Solving this one, you're going to get 1. Solving that one, you're going to get negative 5, so I just need to draw it in. Now, watch this. You know it's going to come up here, and you know it's going to end up there. But how do I do this where I touch that point and end there? Because look, if I go up here like this and I go down, well, how do I cross the x-axis again? I can't because my only x-intercepts are there and there. Okay? The trick here is that whichever one is squared is called something called a repeated root. It's a repeated 0. And so what it does is it's going to bounce off the x-intercept here. So I'm going to go to 1, and it's going to bounce off of 1. So the graph goes up here like this, still goes through 5, but when you get to 1, it's now going to bounce. So I have to start going down and then back up. So it looks like that. So when you have something that's an even function or an even power, it means it's going to bounce. Okay. So right here, oh wait, this is the same problem. Oh, so I guess we're done. Okay, hopefully you guys understood that. If you have any questions, please feel free to reach out to me. Thanks, everybody.